Hello PU2 champions, welcome to day 13 of 21 days challenge to get 95% in your second PUC board exams. As part of today's challenge, I have given you two chapters for revision. The first one is Electromagnetic Induction from physics and the second one is Biomolecules from chemistry. So you need to revise these two chapters and practice its most important questions from the PDF I have provided. If you haven't downloaded yet, the link is there in the description section. Click on the link. Visit the page and download the most important questions PDF and practice these questions. Okay, and in this video we are going to discuss the most important questions from the chapter Electromagnetic Induction. These questions are sourced from previous year questions, model question paper, question bank and so many other relevant resources. So first let's understand the blueprint of this chapter. So this chapter has a weightage of 7 marks. Okay, so you can see 3 mark 1 question, 2 mark 1 question and 2 mark 1 marker question. So total 7. So students, only 75 days are left for your KCET 2026 examination, and if you want to get a top rank in this very competitive examination, then only studying will not help you. You need to take a test series and practice as many as mock tests possible, right? So for that I have launched the Fighter KCET 2026 test series, which is designed by KCET experts and it is based on KCET exam pattern and syllabus. Now here you will get 18 full-length mock tests, 6 each from physics, chemistry and maths. Then you will also be getting detailed solutions, chemistry video solutions, and the most important thing, that is test analysis report. Now all these things are available at a very affordable price of just rupees 399. Okay, the link of this test series is there in the description section. You can go there, click on the link and purchase it as soon as possible, because uh, this offer price will not be the same for a longer period of time. It may go higher later. Okay, fine. Let's see the questions now for 2 markers section. The question is, what is meant by electromagnetic induction? State and explain Faraday's law of electromagnetic induction. Explain briefly the coil and magnet experiment to demonstrate the electromagnetic induction. Second, derive an expression for electromotive force induced in a rod moving perpendicular to the uniform magnetic field. Next, you can see this question was asked in March 2025 also. State Lenz's law in electromagnetic induction. Explain how Lenz's law is the consequence of the law of conservation of energy. Okay. Now we will see some numericals. I have also given you the answers for numericals so that you can check your solutions. The magnetic flux linked with the coil changes from 5 into 10 to the power of minus 3 WB to 3 into 10 to the power of minus 3 WB in 0.01 second. Calculate the magnitude of the induced EMF in the coil. Next, we have a wheel with 10 metallic spokes, each of 0.5 meter long, is rotated with a speed of 120 revolutions per minute in a plane normal to the horizontal component of the Earth's magnetic field, 0.4 into 10 to the power of minus 4 Tesla. What is the induced EMF between the axle and the rim of the wheel? The answer here is 6.284 into 10 to the power of minus 4 volt. Next, the pedals of a stationary bicycle are attached to a 100-ton coil of area 0.1 meter square. The coil rotates at half a revolution per second and it is placed in a uniform magnetic field of 0.01 Tesla perpendicular to the axis of rotation of the coil. What is the maximum voltage generated in the coil? The answer here is 0.314 volt. Next, a vertical copper disc of diameter 20 cm makes 10 revolutions per second about a horizontal axis passing through the center. A uniform magnetic field of 10 to the power of minus 2 Tesla acts perpendicular to the plane of the disc. Calculate the potential difference between its center and rim. And the answer for this one is 3.14 into 10 to the power of minus 3 volt. Next, the electric current in a coil of self-inductance 0.05 H changes from plus 2 ampere to minus 2 ampere in the time interval of 0.1 second. Find the magnitude of the induced EMF in the coil. Here the answer will be 2 volt. Next, current in a circuit falls from 5 ampere to 0.0 ampere in 0.1 second. If the average EMF of 200 volt is induced, give an estimate of self-inductance of the circuit. Answer here will be 4H. Now, a pair of adjacent coils has a mutual inductance of 1.5 H. If a current in one coil changes from 0 to 20 ampere in 0.5 seconds, what is the change of flux linkage with the other coil? Assume no leakage of magnetic flux is there. 30 WB turns will be there, the answer. A coil of self-inductance stores an energy of 3.75 joule where it carries a current of 5 ampere. Find the self-inductance of the coil. Answer here is 0.3 H. Next, the magnetic flux through a coil of 10 turns changes with time as t square minus 2t plus 4 WB, find the magnitude of the induced EMF at t equal to 3 seconds. Next, we have a square loop of side 10 centimeter and resistance 0.5 ohm is placed vertically in a east-west plane. A uniform magnetic field of zero point zero 0.01 Tesla is set up across the plane in the northeast direction. The magnetic field is decreased to zero in zero point 0.7 seconds at a steady state. Determine the magnitude of induced EMF and current during this time interval. Induced EMF is 10 to the power of minus 3 volt and induced current is 2 into 10 to the power of minus 3 ampere. Now the magnetic field inside the coil of length 0.5 meter and area of cross section 100 centimeter square is 1.585 into 10 to the power of minus 10 to the power of minus 3 T. What is the magnetic energy density inside the coil? Also calculate the magnetic energy stored by the coil. So also I have given you the answer here. Next 3-marker question describes Faraday's coil and magnet experiment to demonstrate the phenomena of electromagnetic induction. Explain Faraday's coil and coil experiment to describe the phenomena of electric magnetic induction when there is a relative motion between the coils. Next, derive the expression for the motional EMF in a conducting rod moving in the uniform magnetic field. Obtain the expression for coefficient of mutual inductance between two coaxial solenoids. Mention any three factors on which the mutual inductance between a pair of coil depends. Now, derive the expression for the coefficient of the self induction of a coil. Mention any three factors on which the self inductance of a coil depends. Derive the expression for the EMF induced in a coil due to a varying current in the coil. Next, obtain the expression for energy stored in an inductor. Explain the working of an AC generator with a neat leveled diagram. Okay, next we'll see model question papers 1, question number 25. Calculate the magnetic energy stored in a coil of self-inductance of 0.05 H carrying a current of 0.2 ampere. Question number 36. Describe the coil and bar magnet experiment to demonstrate the phenomenon of electromagnetic induction. Next, model question paper 2, question number 25. Mention the two factors on which the self-inductance of a solenoid depends. Question number 33. Describe the expression for the magnetic energy stored in a coil U is equal to half Li square. For model question paper 3, you can see what is an AC generator and what is its working principle. And question number 33, this is in the 2 markers. In all the model question papers, the first question is on the 2 marker section. The second question is of the 3 marker section. Derive the expression for the motional EMF induced in a conducting rod moving perpendicular to the uniform magnetic field. Now, if I see PYQs of 2024 also, write the principle of AC generator, mention the expression for induced EMF in it. Lenz's law is the consequence of conservation of energy, explain. Now, exam 2, if you see, write an expression for induced EMF in a straight conductor moving perpendicular to uniform magnetic field and explain the terms. Obtain an expression for instantaneous induced EMF produced in an AC generator. Next is describe the coil and magnet experiment of electromagnetic induction. Then we have write an expression for the induced EMF in a straight conductor moving perpendicular to the uniform magnetic field and explain the terms. Obtain an expression for instantaneous induced EMF produced in an AC generator. Then derive an expression for motional EMF induced in a conductor moving perpendicular to the uniform magnetic field. Okay. So after that, we have, as I have already explained you, that KCET 2026 examination is very, very close and a very good affordable test series should be there in your resource list at this point of time. So if you are interested, I have launched the Fighter KCET 2026 test series. You can check that in the description section. This test series is available at a very, very affordable price of just rupees 399. Okay, so please check it. And yes, all the best for your exams. Please start studying hard, and I hope you are doing the challenge seriously. So do let me know about your challenge in the comment section, and all the best once again.